test because I think we can learn from, go ahead, did you start it? I think we can learn from our mistakes, okay? So let's not just kind of, if you struggled with some of these, we need to figure out what it is because you're going to see them again on the test on Friday, okay? So we just need to learn some of the problem-solving skills. All right, so source. If we look at, most of y'all did pretty well on this first one, okay? In a primitive society, okay, so somebody tell me, what are we doing? Where do we, how do you know which one to start with? What's the given? 4 SOP. Okay? Everything else are conversion. All these are conversion factors. So when you're given a bunch of stuff, the thing that only has 1 unit is you're going to be given. That's going to be the good place to start. Okay? Thing that only has 1, because everything else, if it's got 2 units on it, it's a conversion. So this is a conversion between BEFs and TUS, VOTs and BEFs. Okay? So these are all just conversion factors. So this one doesn't really make sense, but it's all about just setting the units up so they cancel. So we start with 4 SOPs. That's over and understood 1. So I know that whatever, I got to find a conversion factor with SOPs in. So I go and I find, oh, 2 SOPs is 3 TUS. And I know that I want to put the SOPs on the bottom. Okay? Same thing, so SOPs cancel, that's how many TUS, and now I got to find something with TUS. 4 BEF over 3 TUS. Now I need something with BEFs in it, so over 2 times. Now again, I need something with this in it, and so I find 5 BUM over, and that comes out to 180 BUM. Now, in terms of sig figs, really you only have 1, so if you put 200, that's really 100% correct as well. But I think I said in class, let's just assume that there's more sig figs. But technically, 4. Now these are, we'll assume these are conversions, but we don't know if they're the same system or not the same system. So sig figs doesn't really apply here. All right. You guys think about it, then the wheels started falling off on these next ones. Okay? Rolls of aluminum foil are 304 millimeters wide and this many millimeters thick. Okay? What is the maximum length? Now the trick on this one is to know that volume is length times width times height. Okay? So you're given a width and a thickness or a height, you're looking for the length. So the volume is going to equal length times 304 millimeters times 0.016 millimeters. Let's just do a capital L so that doesn't look like a 1. So I have 2 variables here. Okay? You must always, if you have 2 variables, this is what I'm looking for. That's what's the length. So there must be some way for me to find the volume. So you kind of work, it's called retroanalysis. I wish I had come up with this, but I didn't. But you start at that question and work your way back to know where to start. And so I know I need volume in order to be able to find my length, my ultimate question. So I need to go back and I say, okay, well, how can I find volume? Well, they give me the density. I know that density is mass over volume, so volume is equal to density times the mass. So volume is equal to the density, 2.70 times, not times, grams over 1 cubic centimeter, times my mass. Well, I did that backwards. I'm looking for mass. I'm going times. Am I doing it right? No, I need the mass. I need the, what do I need? Yeah, I need the volume. Oh, here it is. Okay, so I have 110 kilograms. Something's backwards. Yeah. See, when you do your algebra wrong, you get it all screwed up, okay? Because, none of y'all caught this, volume is gonna equal mass divided by density. Now, here's the thing. How did I know that I was messed up?
The volume units are on the bottom.
Yeah, volume units on the bottom, and grams wasn't gonna cancel out. I mean, it's just, my units just did not work out, and so I'd say, wait a second, something screwy here. Gotta go back, and your units always work. Units are your friend, okay? So, I need mass divided by density for the volume. So the mass, but the density is in grams, mass is in kilograms, so how do we change that? Convert to grams. So we can do this in your head. How many grams is that going to be? 1,100, right? Because there's 1,000 grams in a kilogram. So it's 1,100 grams divided by, divided by 2.70 grams per cubic centimeter. And I don't have this in front of me. What did that come out to? 1083? I think that's the next one.
410.
410? Okay, does everybody agree with that? 410? Those of you that got it right? Okay, so the volume is 410 cubic centimeters. Okay? But this is in millimeters. Volume's in cubic centimeters, 410 cubic centimeters is equal to the length. Now again, we can do these conversions in our head. 304 millimeters is going to be how many centimeters?
30.4.
30.4. We just have to make sure we have all the right units. Times, and again, you're going to do the same thing. You're moving the decimal. It's going to equal 0.0016 centimeters. So it's going to be this divided by the product of these two. And what's the actual? And then I think we have we only have 2 sig figs right here. So answer can only be 2 sig figs, so 8,400. Now some of y'all rounded in the middle, and you got 8,300, okay, which I didn't take off for. Okay, but let's always just plan on rounding one time at the end. Carry extra sig figs, go ahead and just keep it on your calculator and round off one time at the end. Because if you round and you round and you round and you round, you're going to be way farther off. Okay? Does everybody follow me on that? So just round off at the end. Does anybody have any questions on how do you know what to do on this particular problem? Let's not be passive and just sit back. This is the time to figure it out. This is the trick right here, is knowing the volume. Okay, because if I need the length and I'm given a width and a thickness, volume, and then just kind of go work your way backwards. Going once, going twice. Okay, the next problem is pretty much the same. Just a little bit more on the conversions. A thief plans to steal a gold sphere with a diameter of 300 millimeters from a museum. The gold has a density of this. What is the mass of the sphere? But again, volume is equal to 4/3 pi r cubed. Okay? If it has a diameter of 300, what's the radius going to be?
150.
150. A lot of y'all use 300 in here. Okay? The radius is going to be 150, and if it's 150 millimeters, how many, since density is in centimeters, how many centimeters is 150 millimeters? 15. So we want to go 4/3 pi 15 cubed. Okay, because this is 300 with a decimal, so I have 3 sig figs here. So when I divide by 2, which is exact for a radius, I get 115.0, so 3 sig figs. So what's this volume come out to?
4,500 pi.
Which is going to, go ahead and multiply by pi. What do we get? Some of y'all have it right. You have it written on your paper right there. Nobody?
Oh,
I kept it in pi.
you wrote 14,137.
14,137, yes, cubic centimeters. Okay? So that's the volume. But I want, if the gold has a density, what is the mass of the sphere? Well, density is equal to mass over volume. So again, what is the mass? So mass is equal to density times volume. Okay? So again, I know that if I'm going to find the mass, density was given, I had to find the volume. That's how I knew to do this. Okay? Because this, I start with the question, mass is density times volume. So I have the density, I need to find the volume so that I can find the mass. So the density is, where is it? If the gold, 19.3 grams over 1 cubic centimeter times 14,137 cubic centimeters. What's the mass going to be? 273,000. And again, you can carry extra sig figs, but we'll just say grams of gold. But they want it in pounds. So 273 grams, 273,000 grams times, here's my conversion factor, 2.207 pounds. Now, we can shorten this up, because you know how many grams are in a kilogram? 1,000. So just go ahead and substitute in 1,000 grams. Now, if you can do it in 2 steps, put kilogram, then do your 1,000 over, whatever. But you're allowed to shorten up. You don't have to show the conversions on the metric. I'm just trying to show you what work you have to show and you don't have to show. So that comes out to equal 603. And we have 3 sig figs. Everything is 3 sig figs. So we can say 603 pounds. Okay? 300 millimeters, 30 centimeters. That's this width. So we have a sphere that's about this size. Let me go back here. So we have a sphere about this size. Okay? So it's going to be a gold ball. It's going to weigh 600 pounds. So again, when you're watching all the movies and they're stealing gold from the vault and whatever, just know that they can't throw a bunch of those bricks into a bag and carry it, because it's going to weigh a whole heck of a lot. Now, this last one then is, okay, well, we have gold is 1176 per troy ounce. What is the value of the gold sphere? And 1 troy ounce is this many grams. Well, we already have that many grams. So we don't have to do any more work to find that. We already know what that is. So it's 273,000 grams times 1 troy ounce for every 31.103 grams. And I knew I needed grams to be on the bottom. And then it's $11.76 for every 1 troy ounce. So 10,300,000.
Yes.
So that would be a nice haul if you had a gold sphere. Okay? The whole trick. Start with the question, what is the mass? Well, I know density. Well, mass is density times volume. But I have 2 variables. I have volume and I have mass. So I have to be able to find the volume. For this is my unknown. There's got to be a way to find this. So you just have to say, okay, well, volume, what else information do I have? And work your way backwards to know where to start. Retro analysis. Any questions on any of that? Okay, you get to keep this quiz. Okay, it'd be a good study tool for this dimensional analysis type things for the test on Friday. All right? If anybody that's watching this online, if you have a question about anything, email me, and I'll be glad to answer your question. Okay, you can go ahead and stop it.